Recording in progress. Okay, come, I almost forget to start already. Okay, so now, so on the idea here is, okay, in Form 4 Chapter 1, remember, okay, if you need any information in Form 4 Chapter 1, this is on page number 10. Okay, the ways to store chemicals, the ways to dispose chemicals. So these are some basic info for your Form 4 Chapter 1. Okay, so guys, on this seminar, usually what we do is, okay, the notes is already provided. So we give you all the notes. Okay, it's just for those who actually follow me through since last year or maybe until for the past few months, okay, we actually have our notes given to you for every month, right? So these notes is just a simplified version of what we actually have for the past few months. Okay, so we compile everything that we have in this in this idea here is, okay, you have to actually uh, understand from here that we have your midterm seminar, okay, all from 4 chapter 2 chapter 3. Okay, so I'm just going to go through quickly what topics we have, and then we're going to use exercise to start revision. Okay, can I? So usually we try to do more questions in seminar. Okay, so on the idea here is we have your chapter 2 inside got what? Got heating curve, got cooling curve. Okay, so like you see got thermometer, what's the function of it? Okay, water bath, what's the function of it? And most importantly, you see got the yellow highlight one. This is very, very, very common. Every time they ask about heating curve and cooling curve, they always ask you about why constant temperature. Let's say when you do melting, you do condensation, you do boiling, why temperature don't change? Why temperature don't continue go up? So because heat absorb is used to do something else, heat release is used to do something else. So every time you see like heating curve, cooling curve, you see we always highlight the yellow color one. Because that is where you have change of state, which is your solid to liquid, liquid to gas. Okay, then you have your constant temperature. So this is where the idea is we have your explanation. So with all this information, then you go down, we have your atomic structure. So we have your standard representation, nuclear number, proton number, and the meaning of isotope, the example of isotope, okay, and the difference between isotope, the similarity between isotopes. So hopefully all these people have a little bit of memory lah. Will ring a little bit a little bell in your mind. Okay, so but then in your isotope, guys, just to let you know, last year, because I every year go for SPM, okay, so last year SPM, got one MCQ. They asked about this. There's asked about a detector to study the sewage and liquid waste. Okay, so this one, because very similar to this one, see, you look at the hydrogen number 3 and your sodium 24. So a lot of people say that detect leakage in underground pipe, this one use sodium 24. Okay, but then to study sewage is like, longkang. Okay, so you thought longkang and underground pipe is almost the same thing, right? So try to be very strict on this. Okay, if it's for sewage and liquid waste, we use hydrogen 3. Okay, if it's underground leakage, then we say sodium 24. Okay, so this one, specifically hydrogen 3 came out in last year SPM MCQ. Let's say when you wait for the past year to come out, you try to do 2025 past year MCQ, you're supposed to see hydrogen 3 in one of the MCQ question. Okay, so and this is something new. Last time guys, last time in this table, they got lesser example. So now they added something new, which is they added hydrogen 3, they added lead 210. Okay, this one, lead 210 determine the age of sand and earth layers up to 80 years. So which is usually the common one is what? Usually common one is cobalt 60, carbon 14, and then your sodium 24. Okay, but recently they added new stuff. They added lead 210, this one, and then they added the hydrogen 3. Okay, so maybe you guys can be slightly aware on these two lah. New stuff. Okay, in your textbook, the new isotope examples we have. Then after your isotopes, we have your elements and your atoms, your molecules, all the chemical formula. So this one, guys, remember, for those who follow me through the class, you receive a small card, okay, the chemistry card. So that chemistry card is basically the compilation of every ions, positive ion, negative ion, okay, and then your metal, non-metal, your acid, okay. So hopefully you all have this memory about it lah. Okay, so after everything settled, then we have your moles calculation. Guys, we have your number of mole equals to mass over molar mass, number of mole equals to volume over molar volume, particles over Avogadro constant. Okay, so the unit will be gram, okay, dm cube, cm cube. But make sure, guys, in the formula of volume over molar volume, the unit is always dm cube. But then you have to convert to cm cube sometimes. Okay, you have to multiply 1000. Sorry, If you go from DMQ to CM cube, it's multiply 1000. If you go back to CM cube, from CM cube to DM cube, it's divide 1000. So this one, just a quick go through. Okay, then particle include your atom, include molecule, include ions. Okay, so atom, molecule, ion is under your particle type of particles. Then we can actually find your number of particles. Can I ask us example also given? Not gonna go through. But when you do stoichiometry, guys, when you do stoichiometry, make sure you have to do one thing called ratio comparison. Remember when we do mole calculation, got some harder part is like you actually have to do like ratio because the mole you're having is the different from the mole that you are looking for. Let's say you have chemical A, you have chemical B, you have mole for chemical A, but you want to look for mole for chemical B, then you have to do ratio. That one later we do stoichiometry. We're gonna actually see into it. Okay. So after chapter 3, you inside your Chapter 3, we still got empirical formula. So empirical formula got two experiments. One is magnesium oxide, the open and closed cover one, and then your copper 2 oxide. This one is the bridge. Okay, usually I call this the bridge diagram. You have the glass tube bridge. Okay, so it goes over copper 2 oxide powder. So the overall idea here for empirical formula for magnesium oxide is basically the equation. The equation very concept, very good, very important is because for magnesium oxide, you are taking magnesium directly burned with oxygen, you get magnesium oxide. So that is the overall idea. Then we can get the difference in mass before and after heating. Before you heat magnesium, no oxygen. After you heat magnesium, your magnesium now combined with oxygen. So now you have the mass before is without oxygen. The mass after is with oxygen. Okay, so that's the overall idea. If you go down to copper 2 oxide, this one different. This one is started off copper is with oxygen. Then we use hydrogen to snatch the oxygen, become Cu and H2O. So the mass of copper oxide experiment initially is higher, but after the experiment, the copper mass only is actually lower. Okay, now, so the difference between these two experiments is this to this is mass increase. Okay, magnesium to magnesium oxide, mass increase. Then copper oxide to copper is mass decrease because oxygen disappear, taken by the H, become water. Okay, so overall, these are all the surrounding around the pictures is all the common questions. Okay, so later if you cannot find any information, I will show you what where we can get all from the picture. So later we can do calculation, we can do empirical formula and all the diagram. Guys, for the diagram and the procedure, usually for procedure, I give you in the exercise later on, we give you the few common experiment question that you might require to write out the procedure. Means they ask you to describe the experiment. Then you have to write procedure step 1, step 2, step 3, step 4. So what topic very common in your first exam for procedure? Later in our exercise also got. Okay. So if overall okay, then chapter 4 guys, for those who in normal class, we just recently entered chapter 4 So got group 1, got group 17. Okay, but for current progress in our normal class, we only learn until group 1. Okay, so group 17, and then got period 3 and transition element. All this is basically the next few weeks. So for today, guys, my main revision topic is chapter 2, chapter 3. Okay, chapter 4, I don't touch because chapter 4 still fresh. So you're currently learning chapter 4 in normal class, right? Your brain's still fresh about it, about reactivity, about remember the explosion? Okay, you throw into water, got fire, okay? So those chapter 4 topics, right, is not my main point today. My main point is to revise chapter 2 and chapter 3. All good, So guys, right now, let's try to go for exercise, okay? Let's go for the exercise at the back. We start with chapter 2 first. Okay, this one is on page number 11. Okay, page number 11. Page 11. Yeah. Guys, wait. One moment. iPad lagging. Okay, this page number 11. Okay, so I try my best is okay, the plan is every subtopic I try to do one question first. Okay, if got time, then every topic I do 2 questions. Okay, that's the overall plan. That's a idea of what we can actually have for today. Okay, so they ask you with this concept here is here. Okay, we have element RSTU. What is meant by proton number and nucleon number? Guys, definition cannot avoid. And what I said last time, definition is something that you must actually write word to word. Cannot agak-agak. Teacher, I know proton number is number of proton. no use, okay? Because you must write out full definition, exactly word to word, only can get the 1 mark. So actually definition sometimes I say it's a bit not worth it, but then you cannot avoid. Every exam confirm got definition, and what definition gonna come out is random one. Okay, so if you in future we'll give you a list of your definition around like in the whole syllabus or around got 50 definition, 50 50 in form 4 form 5 guys, including form 4 form 5 So 50 definition is kind of a lot, okay? And especially you need to memorize word to word. It's a bit sad lah. But never mind. Okay, we try our best. Especially guys, your first exam because you only exam until chapter 4 is the best time, the best chance for you all to score very well because you only got chapter 1, 2, 3, 4 okay? So the least syllabus in your exam for form 4, okay, for the next future also lah. So you have to be try to score as high as possible lah. If not, you're gonna give up. Teacher, the chemistry very hard. Then you bring this mindset to the next 2 years, then very sad. Okay, so let's try our best. Okay, so from here, see, what is meant by proton number? So we can say that proton number, as we write full definition, we write together, is the number of proton. You'll be like, teacher, I thought you say number of proton cannot use. Not cannot use, is not complete. Number of proton in the nucleus of an atom. In the nucleus of an atom. You see, if you never put the word in the nucleus of an atom, no mark. Is that right? Okay. Then what is nuclear number? Using the same format, means at the same sentence, you also must end with the in the nucleus of an atom. But nuclear number is two number. Total number of what? Total number of proton and neutron. Okay, so we can say nuclear number is the total number of proton and neutron. If you stop here, no mark. So you continue in the nucleus of an atom. Okay, state the number of electron in atom T. So guys, if you look at atom T, it's 39 and 90. So which one is electron? So there's no electron here, but we know electron same number as proton. So 19. Guys, I try to speed up a little bit. If I'm too fast, you let me know. Okay. If no, if I never say anything, I just gonna go slightly faster. Number of neutron of atom T. So guys, there's no neutron. You have to take 39 minus 19, you get 20. Okay. You don't have to actually show the working. You just have to show the 20. So the working I just give you for your understanding lah. So define isotope, guys. Third definition. What is the meaning of isotope? So we have to say isotopes are atoms of the same element with the same something something different something something. Same what Same proton number, or you can say same number of proton. Okay, but I usually I go with proton number lah. Okay, same proton number, but different nucleon number. Okay, can but of course, if you say teacher, usually I use the other package. What is the other package? If you say proton number, you change to number of proton also can. But if you are using number of proton, the nucleon number must change to number of neutron. Okay, so means you either use the red color words or you use my blue color words. Okay, don't mix and match. Don't say same number of proton but different nuclear number. I cannot mix and match. Okay, either the red or the blue, up to you. Okay, but choose one. And which pair of isotopes are of atoms are isotope? So look for same number of proton. So S and U. But guys, if you write S and U, is the teacher will give you wrong. So I have to say atom S and U. Okay, to be safe, you write atom S and atom U. Okay, can I try to always include the word atom? Okay, include the word element or the word. If they use the word element, you use element. If they use the word atom, use the word atom. Okay, can I? And then explain your answer. So we can say, okay, atom S and atom U have same proton number but different nuclear number. Okay, basically definition of isotope, put it in. Okay, say two different physical properties, okay, between two isotopes. So guys, what do you say about physical properties? Physical properties usually we talk about melting point, boiling point, density, okay, electrical conductivity. Okay, so these are the few things. So we want two different physical property between isotopes. So we say boiling point, melting point. Okay, but usually some teacher they take melting point, boiling point as one answer. So you have to try to be safe, you include one more lah, density. And one more, extra one, I give you one, atomic mass. Atomic mass is your molar mass, guys. Basically, when you have higher nucleon, means higher atomic mass. Okay. Will the two isotopes react the same way when heated with oxygen gas? Guys, when they say heated, again, react, this is all about chemical properties. And chemical properties depends on what? Depends on valence electron. So imagine, let's say, now your S is 6 and 6. So 2 at 2.4, 2.4. So because they got the same valence electron, they should react the same way. Okay, so the answer is yes. Okay, so they say would they react the same way? So we say yes. Okay, so we say that both isotopes have same number of valence electron. Hence, both isotopes have same chemical properties. Okay, and then they give you a table, they give you a field, they ask you to write out one isotope under medical field, under agriculture, archaeological, industrial, and state the usage of it. Okay, so with this idea here, guys, of course, I don't expect you guys to memorize everything right now, but at least when we write right here, then you can try to recall back in future in a better memory. So what happened here is, okay, in medical field, usually the common one is called cobalt 60. So cobalt 60, it gives you gamma radiation, just in case you all refer back to your Form 3 syllabus. Your radiation got alpha, beta, gamma. So cobalt 60 give you gamma ray. And gamma ray can do what? To kill cancer cell. Kill cancer cell. Okay, in terms of agriculture, means for plantation, we have this one called phosphorus 32. And this one is to actually do what? We study the absorption. So study absorption of what? For plantation, we have one thing called fertilizers. So of fertilizers. Okay, can ah. Okay, next one, archaeological. So what is archaeological means in terms of your studies of your bones, the fossils. Okay, so can I? So we usually the one common one is called carbon 14. Okay, so carbon 14 we can say to estimate. Cannot say calculate, cannot say other stuff lah. To estimate the age of fossils. Okay, and for industrial we have sodium 24. Okay, sodium 24 for what? To detect leakage in pipes. Okay, so next one will be, okay, they give you PQR. One moment. Okay, suggest the physical states of PQR at room temperature. So guys, first thing you have to record is room temperature. So what is room temperature? Usually room temperature is at your 27 degrees Celsius. Okay, 27 degrees Celsius. So with your 27 degrees Celsius, you have to try to recall in this case, guys. Yeah, they give you melting point, boiling point. The common way that the fastest way you can do is to do what? Is to actually do this. You try to imagine like this. Okay, melting point. Before melting point is what state? So before melting point is solid state. After you melt is liquid. Okay, if after boil, then it's gas kind of. Then you try to take this 27. Let's say I write 27 here. You try to carry this 27. Okay, let's compare. Starting from solid. Is 27 more than higher than the melting point of P? Yes. Is it also melting higher than the boiling point of P? Also yes. So at 27 degrees Celsius, P is a gas. Okay, then you do the same thing for the rest. So 27 start from here. Okay, is it more than 15? Yes. So I move it to the right, to the middle. Is it more than 70? No. So I keep it here. Then for R, 27 degrees Celsius is 900. So 900 not higher, 27 not higher than 900. So it stays at solid. So they suggest the physical state of substance PQR at room temperature. So from here we can say that will be P will be gas. Then your Q will be your liquid. Then R will be your solid. Okay, can Okay, then boron exists as natural isotopes, which are 90% and 81%, 80.1% of boron 10 and boron 11. Calculate the relative mass of boron. So we're gonna actually find relative atomic mass, which is the average of the boron. Okay, so how do you find average? What you can do is you take the percentage, multiply the mass plus the percentage, multiply the mass, then divide 100. Okay, so you all do the maths for me. Come, try to do the calculation and give me the answer in one decimal place. Because they give you one decimal place for percentage, so your answer should come in one decimal place also lah. Okay, yes, some of you gave me the answer. So 10.8 is the answer. Okay, can I? Okay, but then the other possibility is uh we have your isotope given with sulfur 32 and sulfur 34, and they say the relative atomic mass is 32.1. It means that they already give you the average. They ask you what is the abundance of the both isotope. Abundance basically is the percentage. Okay, so just in case you don't know, okay, abundance is the percentage. So how do you actually go backwards? How do you calculate this thing backwards if they already give you the average? So first thing first is you have to set a certain unknown first. Okay, so let's say you need to look for percentage of sulfur 32. So you need to look for this percentage and this percentage. Okay, you have two different percentage. One is the percentage for sulfur 32, one is the percentage for sulfur 34. Correct not? So, but then what I can do is, if I want to find percentage sulfur for percentage for sulfur 32, I can set this as maybe A. Okay. If I want to find percentage of sulfur 34, I can set this as B. Okay. Okay, so I set A and B as an unknown. So what we can know is we take percentage multiply mass plus percentage multiply mass divide 100 equal to what? Equal to the average 32.1. Okay, now you understand? So percentage is A and B. So percentage multiply A, percentage multiply mass, and then divide 100, you get 32.1. Okay, but then what if even if you do like this, you're gonna get something like this. So you get 32A plus 34B equals to, you bring your 100 over with multiply, so you get 3,210. Okay, now you start again. Why? Because you have two unknowns, A and B. So you have two unknowns. Actually, one equation cannot do. So by your maths logic, if you want to find two unknowns, you need two equations so you can do simultaneous equation. So therefore, the other relationship between A and B is what? As we know, A is percentage. B is also a percentage. So between percentage, total percentage is what? So we know supposed to be total percentage is equals to 100. So what we can do is once you have A plus B equals to 100, you do either one. So let's say if I throw my B over, A equals to 100 minus B. Like that. Can? Okay, A equals to 100 minus B. Then you do simultaneous. You bring your A sub into the 32A, the A. So 32 multiply 100 minus B plus 34B equals to 3,210. So you do the maths. So 3,200 multiply minus 32B plus 34B equals to 3,210. Okay, so you do the math. So 3,200 bring over minus, okay, then the negative 32B plus 34B. So we say this is 2B equals to, you bring over, you might manage to find that your 3,210 minus the 3,200, so it goes to 10. Okay, guys, hopefully I'm not skipping too much steps, okay? Okay, all good, Okay, then you can find that B is actually 10 divided 2 is 5%. Okay, so B is 5%, that means the sulfur 34 is 5%. Then how to find sulfur 32? You substitute your B 5% back to the A equals to 100 minus B. So your A is actually 100 minus 5 equals to 95%. Okay, so ultimately, guys, try to be more specific. So B is what? So we can say like this. Conclusion, So percentage of sulfur 32 is 95%. Percentage of sulfur 34 is 5%. Okay, all good? Can I? So guys, hopefully manage to do something like this, because this calculation for percentage, right, is not very common in exam, but some school exam actually includes. So if you can do, then it's better for you, lah. So that's the thing that we can see from here. Okay, so okay, so guys, all good, Okay, so basically, guys, I do one question already, So this one, second question, basically, I let you do yourself, lah. Can I? So I do one question for this topic. So we skip this question, we try this one. Heating curve. Okay, heating experiment, So we have the diagram given here is a setup for determining the melting point of naphthalene by heating a solid naphthalene. The temperature of naphthalene is recorded every half minute. So what is the purpose of using water bath? So guys, when you put into this water bath, what we know is your heat now can come from all directions. If you don't put water bath, the heat of the fire only can come from the bottom. Other directions don't have. So water bath is to give you heat in all directions. So what we can say is to ensure, so the keyword is to ensure even heating. Okay, to ensure even heating. Okay, so that if the question is 2 mark, go one more answer. We say naphthalene is flammable. Okay, then why do we need to stir naphthalene during the heating process? So when we say naphthalene during the heating process, is basically if you don't stir, the outer part get heated up, but the inner part get heated up later. So not fair. So again, when you stir, again we still actually to ensure even heating. Guys, this one also same answer. You can share the same answer. But some teachers don't like this answer for this topic. So you can say to ensure even heating and uniform temperature. So uniform temperature means the temperature is not like inside is lower, outside is higher. Okay, so uniform means you want to make the temperature is like evenly spread. Okay. Explain why temperature remain constant during melting. This is what I mentioned just now. When you doing melting, so temperature go up halfway, suddenly when it start to melt, temperature constant. So this is something very important. So we say that heat energy absorbed. Okay, heat energy absorbed by the particles is used to overcome the forces of attraction between particles to turn from solid to liquid. Okay, so guys, for if the question is is boiling instead of melting. You change everything remain the same, you just change from liquid to gas. Okay, so this one is melting, you say from solid to liquid. But the keyword is same. If you say boiling or everything same, you should also say heat energy absorbed by particles is used to overcome forces of attraction within particles to form liquid, to turn from liquid to gas. That one from boiling lah. Okay, so almost the same. Okay. Sulfur has a melting point of 114. Can melting point of sulfur be determined by using water bath as shown in diagram? So if you say water bath for sulfur, cannot. Why? Because water bath maximum what temperature? Sulfur, water bath, your water maximum is 100 degrees Celsius. So if you want to go more than 100, impossible. Okay, so we can say that the answer is no, because they ask you can or not. You say no. Okay, explain your answer. So we say that boiling point of water is 100 degrees Celsius, which is below the melting point of sulfur. Okay, sketch the heating curve of naphthalene label on the graph, which is the melting point is 80 degrees Celsius. So usually for heating graph, right, the trend is the same. You just have to go up 45 degrees Celsius. Okay, 45 degree. Okay, yeah. Then straight line. Okay, and then go up again. Okay, yeah. Okay, don't forget to label temperature as a y-axis, temperature, and then against time, usually time in second lah. Can time in second or minute also can. They just they never say anything right? Usually is second or minute also can. Okay, then they say 80 is the melting point so you just have to label your straight lines is 80. Okay, the straight line there is 80. Okay, natural abundance of copper. Okay, guys, I think this one is something similar just now to find the relative atomic mass means you actually want to find the average. So just a quick one, okay? So percentage multiply mass plus percentage multiply mass divide 100. See what you got? Okay, we'll try this. Just one quick one. The next one I don't even want to do already. Next one is to find percentage, something similar like the first question. Okay, so someone give me answer. Okay, guys, for this one, guys, how many decimal place do you give me? Is it one decimal place? So no, for here the percentage give me two decimal place, right? So you follow two decimal place. So 63.62%. Okay, hopefully you all managed to get this. Okay, so heating curve, cooling curve. Okay, we do heating curve already one time already. Okay, then I leave one more temperature question for you guys, okay? So we can do the third type of question. It's about kinetic theory. Okay, your kinetic energy. So this one, finish. Okay, guys, this one I don't know do. You do yourself, okay? So next one also you do yourself. Okay, this one. Question number 15, this one, question 3A. Okay, compare the properties of particles in diagram. Okay, so this is a solid, this is a liquid, this is a gas. Okay, so how do they arrange? Okay, so what's the keyword for arrangement of solid? So if they ask you to describe a solid arrangement, so we say that, okay, particles are closely packed. Okay, use the word closely packed and orderly manner. Okay, we say arrange in orderly manner lah. Arrange in orderly manner. Okay, then for liquid, usually we say particles are further apart and not orderly arranged. Okay, then gas with particles are very far apart and not orderly arranged. Okay. Then the movement of particles. So how do they move? So for solid particles, they look like they don't move, right? But cannot say they don't move. They actually move, but in a very, very minor way. So we say that vibrate and rotate at fixed position. Okay, vibrate, rotate, and fixed position. Then for liquid, you can say constantly moving freely. Okay, then how about gas? Also constantly moving freely, right? But add one more word. So constantly moving freely because gas can move faster, so moving freely at high speed. Okay, how about the attraction force? If very near, guys, attraction force is about distance. If very near, then strong attraction force. So we can say strong. If further away, so we can say moderately weak. Moderately weak. Then if very far apart, very weak. Kinetic energy, it depends on the movement. So if only vibrate and rotate, so it's low kinetic energy. Then this one is moderately high. And then lastly is very high. Okay, guys, this is essay. For those who wondering, teacher, like, do we do essay question? Can we do essay question, guys? This one here is actually essay question. Okay. So just in case you're all wondering, teacher, essay is what? Is it like writing essays? Is it like writing like a few paragraph? Guys, in chemistry, biophysics, essay question is just that you have to use more stuff to explain. Again, no need, there's no specific format. Even like this here, do you see this is 12 marks? In exam, right, you just have to actually draw this table, fill up all this information, you get 12 marks. So means in essay, you can use table format to answer. There's no specific way or no specific format to answer essay question. As long the answer fits perfectly, got keyword, okay, it's tidy, okay, easy to understand, teacher can mark, then can. Okay. So that's why when they use the word compare, when they say the word compare, I always prefer my student to do table format. Answer your question in table. Okay, try to construct a table and then try to put your keyword inside, then you can get your marks very easily. Okay, now. So you see, if you go and write essay, if you go and like write paragraph, maybe you're gonna write even more words, right? Now. So actually, it's not about the wording. When you write more, does it mean that you actually get more marks? No, it's all about whether you hit the keyword or not. So this is a type of essay question. Okay, so we are already doing essay question, just in case you are wondering, okay? And then let's see, 9 marks, also essay question. Whenever you see like 7 marks, 8 marks, 9 marks, 10 marks, all this is essay. But as I said, is there any specific way to answer? No. So let's say for this case, you see, a student carry out an experiment to determine the melting point of acetamide. So what's acetamide? Don't know, but never mind, don't care. Because in exam, you have understand that sometimes in exam, right? You might not get everything you know in your brain. Okay, so stuff that you don't know. But as long as you know the concept, it's the same thing. The melting point of acetamide, the right diagram shows the heating curve obtained, changes in physical state labeled as PQ, R, and S. So write the physical state for PQ, QR, and RS. Explain the changes in temperature and physical state of acetamide that occur in every phases. So if you look at 9 marks, which is they ask you to split your answer into PQ, QR, and RS. So what you can do is you can divide equally 3 mark, 3 mark, 3 mark. Makes sense, right? So now we guys no need to write in table. You want to write in table also can. But for now, if I don't write in table, I go by paragraph. Also okay. So I'm showing you that we can also do paragraph. So paragraph like what? Like this PQ, like this. Okay. So first of all, what is the physical state at PQ? So this is melting point. Melting point means what? Before you hit the melting point is solid. When you are at the melting point is solid and liquid. When you finish melting is liquid. Okay, now make sure you understand this. When during the constant temperature, you have two physical state because you are like changing your physical state. So with the idea here is your PQ, we know that it's number one, solid. Okay, solid. Full stop. I don't know, guys, legit, just write solid. No need to write, guys. Don't put bullet. When you're doing essay question, don't put the dot in the front. Okay, just write solid. Okay, then explain why is it solid? Because at this point, is it melting? No, it's just temperature increase. You're just heating your chemical. It's just absorbing heat. Okay, particles are moving faster, but it's not melting. Okay, so we say that temperature increases. This is they say change in temperature, right? So they want to write 3 things. Physical state, explain temperature, explain physical state. So this time we say temperature increases. Then we say solid particles absorb heat, energy, and vibrate faster. Because solid, guys, solid we say vibrate faster. Causes kinetic energy increases. Okay, so 3 mark already. Then go for the second category, QR. So we can go for QR. QR this time, is it solid or liquid? It's both because it's halfway through melting. So we said that okay guys, in exam, say, teacher, can I write solid plus liquid? No. Can I write solid and liquid? Also no. Why? One very strict word you must say is mixture of solid and liquid. Okay guys, I'm not kidding you. You must write the word mixture of solid and liquid. Okay, then we say that. Then you just start to use the keyword we just now learned in the heating curve. Okay, heat energy absorbed is used to overcome the forces of attraction between particles to turn from solid to liquid. Okay. Yeah. Then how about RS? So guys, this one finish. This one got 3 marks already, yeah? Because this one got, so I say energy absorbed to do what? Okay. So what we can say is, so RS okay, so the RS will be liquid. Yeah, and the keyword is exactly the same as your PQ, but not solid particle anymore. Now it's liquid particle. Okay, so we can say liquid. Okay, so guys, temperature increases. So we say temperature. Oh, guys, for this one, I forgot to say temperature. Yeah, whenever I hear temperature for second one, temperature no increase decrease, right? Remain constant. See, I forgot to write temperature. I realized when I writing my last one. Okay, so that for last one is temperature increases. So we say liquid particles absorb energy, heat energy, and move faster. Causes kinetic energy to increase. Okay, guys, essay question. Okay, now so you all don't because you all see the word essay, you all be like, teacher have to write like 6 paragraph, okay, 180 words, okay, no need this is not BM, this is not BI, okay. So all you have to do is try to read the question properly and what is the answering technique, sometimes table format, sometimes in a paragraph format, okay. So you see all this is how we answer essay question. Okay, so guys, after finish chapter 2, guys, we're done with chapter 2 questions already. Now we move on to chapter 3 question. So chapter 3, as we say, got empirical formula, got moles calculation, got stoichiometry, and then got the chemical formulas and those things. Okay, so move on to next page. Okay, question 4a, the next type of question. So by looking at the bridge, you see the glass tube bridge, we know it's empirical formula of who? Of copper oxide, or copper 2 oxide. So okay, now guys, what is the definition of empirical formula? Okay, so we got definition for empirical formula, which is what happened here. What is the definition for empirical formula? Will be okay. So we have to start with the same thing, no? So the same word, empirical formula is chemical formula that show what? That shows the simplest whole number ratio. Okay, if you stop here, congratulations, no mark again, because you have to end your sentence with simplest whole number ratio of atoms for each element in a compound. Hard to memorize, right? Guys, you see got what? Definition for proton number, definition for nucleon number, definition for isotope. Now we got definition of empirical formula. Still got what? We still got definition for molecular formula. So if you got definition for molecular formula, what do you modify? You modify the word simplest whole number ratio. You say change it to actual number ratio. Okay. So just change the word simplest whole. Okay, change it to actual. then that is your molecular formula. Okay, just in case you need that lah. How do you dry the hydrogen gas? Okay, so for this one, guys, this one question, can you cancel it for me? This one no more already. This one is old question, old syllabus. So you all cancel this for me. So ignore this. We go for C. What is the purpose of using zinc granule and hydrochloric acid? So guys, if you remember, I told you this experiment. The idea is CuO use H2 to snatch the O become Cu and H2O. Right? So with this concept, you need to have H2. But where do you get H2 from? H2 don't come from like normal gas. So you need to have a specific experiment to produce the H2 that you can actually use it to snatch the O from the CuO. So that's why, where do you get H2? It's your zinc and hydrochloric acid. So when I ask you what's the purpose of zinc and hydrochloric acid, you have to say to produce hydrogen gas. Okay, but how do the equation looks like? What is zinc? Zn. What is hydrochloric acid? HCl. So what happened to that? The zinc will snatch the girlfriend, the Cl. Then kick off the H. So become ZnCl2. But guys, why suddenly become ZnCl2? Because when Zn combined with Cl, Zn is 2 plus, Cl is minus. So 2 plus and 1 minus, swap number, you get ZnCl2. Okay, and don't forget, when your H got kicked out, it's a gas, hydrogen gas. So 2HCl. So you have a H2, Cl2, and then we balance the equation by 2HCl. Yeah, and what change can be seen after the oxide of copper is heated strongly? Okay, guys, just in case you all don't know, what was the original color of CuO and what is the color after heated for your Cu? And okay, so for those who forgot, the color for CuO is actually brown. Okay, color of sorry, Cu is brown, guys, my bad. Okay, brown is also okay, and then CuO is black. So your answer here is supposed to be black solid turns brown. Okay, so after the idea, now we have your results without anything. With just a tube and a paper is 135.15. With copper is 147.95. With oxide of copper is 151.15. Okay, so with the idea here, how to determine empirical formula of oxide of copper. So we can say that CuO. Okay, mass of Cu. How to find mass of Cu? So let's say for here, to find copper is this one. Okay. But how to find copper only? Minus off the tube and the paper. So we take 147.95 minus 135.15. While for oxide is here. To find oxygen is this one only. So I have to minus off the tube, the paper, and the copper. So we take 151.15 minus 147.95. Okay. So this one hopefully you all got a bit of memory because actually we did this in our normal class last time long time ago. Okay, so what you're getting for the first one, 12.8. Okay, good job. Next one is 3.2, is it? Okay, so ultimately, guys, how to find moles? You take mass over molar mass, and to find ratio, you take the mole divide the smaller number of mole. So guys, this I don't not gonna do it with you, you do it yourself. So ultimately, you should get 1:1 ratio. Empirical formula is CuO. Now guys, bear in mind, in exam, the table is not provided. This one not provided. You need to write everything here and draw out the table by yourself and write the conclusion yourself. Okay, write the balanced chemical equation for the reaction between oxide of copper and hydrogen gas. So guys, I actually gave you this one just now already. So CuO plus hydrogen gas. Then you get Cu plus H2O. Okay, the good news is already balanced. Okay, why does the hydrogen gas need to flow continuously for a while before starting the heating process? Okay, isn't it? It's actually this thing we discussed before a long time ago when I teach you this topic. Before you do this experiment, you cannot straight away start heating because you have to let your H2 flow for few moments first, maybe like few seconds or maybe 1 minute, 2 minutes like that. So the reason for that is because if you don't let it flow, you start heating it immediately. The copper 2 oxide will actually react with few things. Okay, example, we have oxygen gas in the tube, and then with the mixture of H2 coming in, your H2 and O2 mix, you heat, this thing will explode. Okay, this thing is actually explosive. So if you actually if you never flow, because the idea is you flow is to push out all the air. If you don't push the air and H2 explode. Okay, when you heat, it explodes. Okay, so basically from here we can say that to remove all the air in glass tube. Okay, can empirical formula of magnesium oxide determined with the same method? So guys, if you remember, magnesium oxide is Mg plus O2 using become MgO ma. But this experiment is use H2 to snatch the O. So the idea is now, if you imagine you change CuO to MgO, can H2 still snatch the O from MgO? The answer is no, because based on what you learned in last time from Form 3, Form 2, we have the reactivity series of metal, right? So your hydrogen is not able is actually less reactive than magnesium, so cannot. So from here we can say answer is no. Okay, because you say magnesium is more reactive than hydrogen. Okay, then hydrogen gas is allowed to flow until the product of heating is at room temperature. Means guys, before you heat, you flow. After finish heating, you still flow. But different reason lah. Okay. So if you finish heating, okay, if you finish heating all the stuff, okay, technically is you still need to let your H2 flow. Means your fire no more already, you still let the H2 to flow. But why? Because if you don't do that, okay, you don't let your copper cool down because the idea is after you heat this copper when you form is hot copper, and this hot copper, if you never let it cool down with all the H2, you straight away remove the rubber tube, the oxygen will enter, and this hot copper will react with oxygen, become copper oxide. So it means it go backwards. So cannot. We don't want the hot copper react go backwards. So what we can do, let him cool down. Okay, let the H2 flow. Okay, while waiting for the copper to cool down. Okay, so that's the idea here is to prevent. Okay, to prevent air from entering the glass tube because oxygen in air will react with hot copper to form back copper 2 oxide. Okay, why do heating, cooling, and weighing process is repeated until constant mass is obtained? So guys, this experiment usually got no ending one. Because you never know when's the final mass. Because you think about it, this experiment is like this. You started off with 151. Then after reaction, let's say you started off with 151 grab, okay? Then how you know 147, like 151, then drop to 148, okay? How you know is what 148 is the final mass? Right now. What if you continue hit? What if you continue do? It becomes 145. What if you continue do become 144? How you know right now? So you never know when is the final mass. So the only way to know is by doing heating, cooling, weighing process repeat until constant mass is obtained. Okay. So we can say that to ensure all copper 2 oxide are completely reacted and change to copper. Okay, so guys, I do one question of copper oxide already. Let's do one question of magnesium oxide. So this one next one. So next one I ask you, what is the meaning of molecular formula? So this one we purposely one, okay? So do we do one question for empirical formula? We ask you one question for molecular formula, okay? So we can say that molecular formula is chemical formula that shows the actual number of atoms for each element in a compound. Okay, so by doing this, guys, I think you can do it yourself for the empirical formula. So just a quick one, okay? To find magnesium oxide empirical formula, guys, make sure in exam, again, table not provided, all these not provided, element, mass, number of mole, ratio, all not provided, must do it yourself. Okay, so to find mass of magnesium, we take 39.7 minus 38.5. To find mass of oxygen, 40.5 minus 39.7. Okay, so this one here, you should get 1.2. The other side, you should get 0.08, if I'm mistaken. Then 1.2 divide 12, 0.8 divide 16. Okay, you get 0. Divide 24, guys. Why did I write 12? Divide 24, so 0.05. 0.05, ratio 1 to 1, empirical formula is MgO. Okay, write the chemical equation for the reaction in the experiment. So guys, it's very easy because you just have to have Mg plus O2 becomes MgO. Okay, not about snatching girlfriend, just direct heating. So this one, balance equation, balance equation. Okay, why was the crucible covered with lead as soon as the magnesium started burning? So guys, when you do this experiment, you open and close the cover, okay? Open and close the lid, okay? So why you cover? Why you cover? When you cover, is to avoid something from escaping. Because when you burn magnesium oxide, it's a white film. It's a white fine powder that if you don't cover, the fan blow a bit, all the white powder fly away, okay? So this one here, we can say to avoid, or you can say prevent, white film of magnesium oxide from escaping. Okay, why is this method not suitable to determine the empirical formula of copper 2 oxide? Guys, because if you try to imagine, I change this to copper plus oxygen become MgO. Actually, this one not suitable because copper is less reactive. So if you heat with oxygen, very slow. You have to waste like half an hour, 1 hour. Okay, also cannot finish the experiment. Okay, so we can say that copper is less reactive towards oxygen. Okay, so it's very slow technically. I mean, you can, but very slow. So the better way and the faster way is to do the glass tube experiment, the previous one, for copper oxide. Okay, and lastly, and explain how to ensure the reaction has completed, guys. Remember this time what we did? Same, guys, even though different experiment, but the way to get your final mass of your result, you cannot just do one time, then you consider done. Okay, because and the idea here is you need to always repeat 3 steps. What's the 3 step? Heating, cooling, and weighing until constant mass is obtained. Okay. Okay, so we can say heating, cooling, and weighing process are repeated until constant mass is obtained. Okay, and what are the 2 steps, 2 precaution steps that must be taken during the heating process? So guys, when you're heating, what do? Open and close. So we can say lid must be open. But when do you open? Guys, it's like once in a while. So we say it must be open at interval to allow oxygen gas to enter and react with magnesium. Then what do? We have to close it back. Close for what? Just how we say it. So the lid is then quickly covered to prevent escaping of white fume. Okay, so guys, can all good So I leave one question for you guys to continue do, okay? Okay, we got a few more questions so you all can practice more, okay? So now let's try to go for the most calculation, the empirical formula, the most calculation, the stoichiometry. Okay, so this one experiment, the empirical formula for magnesium oxide and copper 2 oxide, we officially done. Uh still got a few questions, you see. So we're like one question, got like two questions. Okay. So still got two questions. You all can try it yourself. Can So next one, we can now go for page number 20. Page 20, Okay, so in your common exam, right, high chance that your exam paper will give you some random weird drawings, okay, like this. Look at this. Guys, what is this? You also don't know, right? Okay, but they say this is actually paracetamol. What is paracetamol? The common name that you all know is actually Panadol. Panadol is a brand name, okay? So paracetamol is the actual name. So chemistry name for Panadol is called paracetamol. So it's a commonly used medicine that can help to treat pain and reduce fever. It's typically used to relieve mild, moderate pain such as headache, toothache, sprains, reduce fever caused by illness such as cold and flu. So now, adults can take two 500 milligram tablets 4 times in 24 hours. You must wait at least 4 hours between doses. Do not take more than 8 tablets in 24 hours. So guys, they give you so many information about paracetamol. They ask you, what is the chemical formula of paracetamol? Guys, what is chemical formula? Chemical formula is like CuO, MgO, Mg, oxygen gas. So okay, basically chemical formula is a symbol. So guys, how you know the symbol? The teacher, how I know? They give you the picture, ma. Use the picture lah. So technically, guys, you just have to count how many C, how many H, how many O, and then write down. Okay, now. So what you can do is, you see, so let's say, okay, usually, guys, you usually count the C first, but in your case, actually the sequence doesn't matter. You can count any element first, Okay, so with the idea here is you have your uh CHO, all these things here. Okay, so we have we see what kind of element first. Okay, we got what? We got carbon, we got hydrogen, we got oxygen. Anything else? I got one more, nitrogen. See, this one got nitrogen. Okay, so we got four things. Got carbon, got hydrogen, got nitrogen, got oxygen. So guys, how many carbon you count? So 1, 2, 3, 4, 5, 6, 7, 8. So guys, C8. How many H? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 3, right? Because this is 3, H3, so 9. So H9. Okay. Then how many O? 1, 2. Okay. Then 1N. Okay. So O2N. 1 mark. So guys, so usually when you see a question like this, right, don't be afraid. They usually just give you a weird and random drawing. They would most likely just ask you to draw the not draw, write out the chemical formula. If they ask you molecular formula, chemical formula, just do like this. Okay. What is the relative molecular mass of paracetamol? Guys, what is relative molecular mass? Molar mass. Relative atomic mass, relative molecular mass, all is molar mass. So how do you find molar mass? Substitute relative atomic mass into your chemical formula, plus together is your answer. Okay, so you 12 times 8, because 1C is 12, so 12 times 8 plus 1 times 9 plus 16 times 2 plus 40. Okay. So you plus together, then you should get some number. So 8 times 12, 96 plus 9, 104 plus 48, 100. Wow, cannot bring, guys. cannot bring. Uh, okay lah, guys. Let's make good use of the technology lah. Okay. So what you got? What you got for this? 151. Thank you. Okay, 151. Okay. So what is the molar mass of paracetamol? Be like, teacher, I thought you said this is molar mass. Yes, guys. Molar mass is basically relative molecular mass with a unit. Okay. It means that it will be 151 gram per mole. So that this is the unit for molar mass. Okay, unit for molar mass is gram per mole. Okay, but hey teacher, I thought you usually say molar mass no unit, right? Guys, actually molar mass got unit one, just that we don't need a unit in your formula for moles calculation. Okay, so just to clarify, guys, molecular mass and molar mass is exactly the same number, just that one is without unit, one with unit. Okay, yeah. Then calculate the number of paracetamol molecule in 500 milligram tablet. So guys, look at the question, what they want. Number of molecule. So what is number of molecule? Number of particles, which is NOP. Okay, but then guys, how do we do this question? Usually to find NOP, you need moles. But do you have moles? No, but we can find mole. How? By having the mass of the tablet. Okay, so if you got mass of tablet, what can we do? First formula, number of mole equals to mass over molar mass. Okay, now, but one thing, guys, if what happened here is they got 500 milligram, but you cannot use milligram. You must use gram. So how do you convert milligram to gram? This one test your physics a bit again. I think your physics got learned before this. This conversion of these numbers. So for 500 milligram, usually is 500 milligram is equals to, guys, actually to gram is 1 gram equals to 1000 milligram. So for milligram back to gram, divide 1000, so 0.5 gram. Okay, then you put in the number 0.5 and the molar mass is 151. So you press the calculator, 0.5 divide 151. So you get 0.00331. Okay, there's a lot of decimal place lah. So I take like 3 significant figure or 4 significant figure. Okay, so something like this. The more you take, the more accurate it is. Okay, then we can go with by molecule. So for molecule formula, we can go with number of mole equals to number of particle over Avogadro constant. Okay, and guys, remember Avogadro constant? No need to memorize. Given by the question, 6.02 times 10 to the power of 23. Then the number of mole is 0.00331. Okay, so you do the math, bring your number over. What is your number of particle? So 0.00331 multiply 6.02 times 10 to the power of 23. You should get, what do you all get? Give me your answer. Okay, so you get 1.99 times 10 to the power of 21. Very good. And the unit straight away is molecule because the chemical right here obviously is a molecule. So many things combined together, molecule. Okay, calculate the maximum number of mole can be taken by an adult. By an adult, why got grammar mistake? Sorry, guys. Okay, so what is the mole of maximum mole can be taken by an adult? So maximum, how many tablet per day? Maximum 8 tablets per day, maximum, and each tablet is 500 milligram. So what we know is 8 tablet means 8 times 0.5 gram. Okay, because milligram to gram is 0.5. So 8 times 0.5, what do you get? You're gonna get. Oh, guys, don't even need this. You know why? We already have the mole for one tablet, right? This is the mole for one tablet. Right? Not? Because this 0.5 is for one tablet, right? So I just have to take 8 times 0.00331. Okay. No need to think too much. Just 8 times 0.00331. You get 0.02648 mole. So this is 8 tablet. Because this one is the mole for one tablet. So mole for 8 tablet times 8. So this is the answer. By the way, I forgot to put a unit mole. Okay, so determine the mass of 0.1 mole. Guys, if you have 0.1 mole, that's number of mole equals to mass over molar mass. So 0.15 mole, mass is not, mass is the thing you're looking for. What's molar mass? So molar mass is the 151. Okay, so mass is 0.15 multiply 151. 22.65 gram. Don't forget the unit gram, guys. It's a mass. So gram. Okay, guys. So do you even need to know why the paracetamol looks like this? No need. Okay, so just in exam, right? Please make sure that don't get nervous whenever you see like, teacher, what is this? Oh, so girly, just disgusting. Guys, don't worry. Okay, it's gonna be something that you already learned before lah. And all good. Okay, so if this one no issue, okay, moving on. Okay, 7B, you all try it yourself, okay? Can so 7B, 7C, okay, we give you like vitamin. Okay, got banana. Okay, got banana, got vitamin, all these things, okay? So this one, give it a try yourself, okay? We look at question number 8A, so page number 23. Okay, so this one is a normal empirical formula, not your magnesium oxide, not your copper 2 oxide. Okay, okay, so what you can do, so this is a quinine. So quinine is a drug used to treat malaria. You might not know what is all this, but if you just remember, malaria is something like dengue fever. Okay, so this is the medicine. So it shows that it contains 74.10% of carbon, 7.4% of hydrogen, 8.64% of nitrogen, and the rest is oxygen according to mass. Okay, so on the idea here, very simple. If they give you percentage, don't care, just use as your mass. Okay, so it means 7.74.10, and then hydrogen is 7.40, nitrogen is 8.64, and the rest is oxygen. You just have to know that percentage maximum is 100. You take 100 minus all these three numbers, you get the percentage of oxygen. Okay. Okay, so 74.1, 7.4, 8.64 minus 100, you get 9.86. Okay, hopefully you all can do this. So guys, so basically the rest is the same. What are you gonna do? Mass divide molar mass. Okay. Okay, so you're gonna do 74.1 divide 12, 7.4 divide 1, is that 7.4? And then x.64 divide 40, 9.86 divide 60. Okay, so let's go with two decimal place because they gave us two decimal place. Okay, so two decimal place. So you should get 6.2 is on 0.62 is on 0.62 if not mistaken. Okay, then what you're gonna do? What you're gonna do is you actually have to take everyone divide by the smallest number, which is 0.62. So 6.2 divide 0.62, 7.4 divide 0.62. These two is 1. Okay, because same number ma. Same number divide same number, then it's equals to 1 lah. So only these two need to count. Okay, so this one is 10. And then if 7.4 divides 0.62, you will get 12. Okay, you should get 11.9 something lah, but 0.9 something is can be round up to 12. Okay, so with this, everyone is whole number already. So 10, 12, 1, 1 is C10, H12, NO. Okay, all good. So hopefully you all can continue with the normal empirical formula. Just the same thing. Okay, just sometimes you can see some weird decimal place. Set yourself lah. Maybe 1 decimal place, maybe 2 decimal place. Okay. Okay. Someone say, "Hi teacher, I'm from 5 student actually. Can I join your seminar class?" I mean, sure. This is free for all. You join to revise for 4. Okay. No worries. But you are missing out other subjects lah. Just to let you know. Let's say you're from 5, right? You can actually you're supposed to go for today's MX. So you're missing out MX. Oh yeah, chemistry exam tomorrow lah. Okay lah, can lah. So how to find O if they never give O? Because they say the rest is oxygen ma. So percentage maximum is 100. So you take 100 minus all 3. Then you get this. Okay, can percentage maximum is 100. So to find the remaining, you take 100 minus the rest. Okay. Can means you take my 100 minus this, you get 9.86. Okay, so moving down. Molecular formula. Okay, so molecular mass of quinine is 324. What is the molecular formula of quinine? Which is, guys, if you remember, empirical formula is just the simplest whole number format for a chemical, while molecular formula is the actual number. It means that there is a simple relationship between your molecular formula and your empirical formula. So what is the relationship? So let me just give you a simple concept. Okay, this formula is not provided in anywhere. Yeah, in any textbook. So we say that empirical formula. Yeah, so empirical formula. If you want to convert back to molecular formula, you need to multiply a certain number to turn into molecular formula. Okay, so how do you do this? Usually is you have to first substitute your empirical formula first. You already have your empirical formula given by the question. So you calculate from the previous question. So C10 H12 NO, and then you have to multiply a number, but the number is unknown. Okay. You're not sure. Okay, you're not sure what is the N. Okay, but then the teacher, if I'm not sure what is the N, how am I supposed to find the molecular formula? Right now. So that's why they give you a hint. The molecular mass is 324. Means the molecular formula, total up everything is 324. So with this info, you first equal this thing to the 324 first. Then you substitute all the C, the H, the N, the O with the atomic mass. Find the N. So it means you do the maths. So you do like 12 times 10 plus 1 times 12 plus 40 plus 60 multiply N equals to 324. You substitute all the atomic mass of your C, your H, your N, your O into it. calculate the number. So 120, 132, 146, 162. Is it? Guys, I use my maths, my quick maths brain, even though it's rusted a bit, okay? I hope correct lah. This one. Is it 162? Is it 162 n equals to 324? Yes, okay. So technically, you can throw your 162 over. So 324 divided 162, you shall get 2. Okay. So do you realize you found the number that you're supposed to multiply it? So now we can say molecular formula equals to C10H12NO multiply 2, you get C20H24 and 2O2. You just expand your 2 to everyone in the formula. That is the molecular formula. Okay, guys, make sure you know how to do this because most likely your coming exam, when they ask you to find empirical formula, high chance the next question is to ask you to convert it back to molecular formula. You have to remember this relationship. Okay, this red color formula relationship, not in textbook, is for your own understanding. Okay, all good. So next one, find the number of atoms in 20 gram of quinine. So guys, if from the first idea is okay, so what we can say is in your idea on 20 grams, so we can say number of mole equals to mass over molar mass. So mass is 20. Then guys, what's molar mass? Do you have molar mass? They literally give you relative molecular mass. That's your molar mass. So it's 324. Okay, so 20 divided 324. This I cannot print. I use calculator. 20 divided 324 is 0.1061728. Oh, a lot of number. Okay, so I go with 0.617. Okay, 0.062 also can. 0.617 also can. Okay, but they want to find atom. Guys, to find atom is find what? Find number of particle. So same thing. We do number of mole equals to number of particles over Avogadro constant. So number of mole is 0.0617. Your Avogadro constant is 6.02 times 10 to the power 23. So what is your number of particles? Okay, so you all give me the answer for this. Because my computer calculator cannot press this times 10 to the power 23. Okay, I need your calculator, your scientific calculator. Okay, someone gave me 3.71 times 10 to the power of 22. Is that all you're getting? 714. Okay, so someone give me 3.714 also can. So means I move this a little bit. So 3 decimal place also can, 2 decimal place also can. Okay. Up to you lah. At least 2 guys. At least 2. At least 2. Minimum 2. Okay. But guys, if you stop here, you are wrong. Why? Because quinine, so many things combined together. Got C, got H, got N, got O. Is that an atom? Do you think quinine is an atom? No. So many things mixed together, it's a molecule. So the unit follow the symbol, molecule. Then you'll be like, teacher, but then they want atom or but this one is molecule or how leh? So to convert molecule to atom, you multiply the number of atoms. Okay, so what's the meaning of that? Look at quinine. The actual formula got how many atoms? Got 20 carbon, 24 hydrogen, 2N and 2O. So 20 plus 24 plus 2 plus 2. So 44, 48, 6, 48. So got 48 atom. So means that you take this, multiply 48. You take your 3.714 times 48. So guys, remember, to convert molecule to atom, you multiply number of atom. So to multiply this, so what do you get? What's your final answer? So 1.78, someone give me 783 also can? Times 10 to the power 24 atoms. Okay. So guys, just a recap. If you are looking for molecule, no need to multiply anything. But if you are looking for atom, which is a molecule got how many atom, you have to multiply the number of atom. So this one is extra step. If your chemical is molecule, you want to find atom, you do this. Okay. But if the chemical is a molecule and you're looking for molecule, then no need to multiply anything. Like what? Like this one. Remember the previous question that we do? Do you see here I stop at molecule? Because they want to find molecule. So want to find molecule, then just molecule. Okay. So understand. Okay. So hopefully you all can manage to get this. All good. So got few more questions very similar at the back. Okay, so guys, technically, you see, the question number, we match with the alphabet, right? So I only do all the A with you. So like, see question 8A, you got question 8B, question 8C. So all these are similar questions. Okay, so the A, B, C is similar question. But when you go different number, is different type of question. Okay, you understand how it works, So you see 8B, 8C, 8D. Okay, we got three similar questions. You all can try yourself. And lastly, we can go for question 9A, page number 27. Okay, page number 27. Okay, so now we have ethanol burns in air according to the following equation. So this one is given. Okay, so guys, if exam never give you equation, most likely you have to draw your own, you have to write your own equation lah. Remember, so equation, okay, for your equation, you have to actually write your own equation. If it's not, then sometimes it's provided lah. So now, if 9.2 gram of ethanol is burned completely in air, calculate volume of carbon dioxide produced. Guys, this is under stoichiometry. You know why I call this stoichiometry? Because they gave me mass of ethanol, 9.2 gram, but you're looking for volume of carbon dioxide. Do you see? He give me mass for one chemical, but he asked me to find volume for another chemical. You realize that? So this is stoichiometry. Whenever they give you something and you look for something else, stoichiometry. Excuse me. So guys, morning sinus. Okay, so now in 9.2 gram, what can we do? We can do number of mole of your ethanol is actually mass over molar mass. Why mass over molar mass? 9.2 gram is obviously mass. So we put in 9.2. But what is the molar mass of ethanol? So ethanol is the C2H5OH. Okay. So of course, you say, teacher, how I know ethanol is this one? Because you never learn before what's ethanol, right? But by logical prediction, even if I don't know what is ethanol, they say ethanol burned in air according to the following equation. So air is which one? Oxygen. So who is most likely is your ethanol? The C2H5OH. Okay now. So in exam, you sometimes you also need the skills to identify something that you might not see before, but it can be found through elimination. So we know oxygen is air. Then ethanol cover this one. Okay now. So what is the molar mass of C2H5OH? You have to do separately. The C2H5OH will be 12 times 2 plus 1 times 5 plus 16 plus 1. Okay, C2H5OH. So 24 plus 5, 39. 46. Okay, so the molar mass is 46. So 9.2 divide 46, you shall get 0.2 mole. Can? But guys, you want to find carbon dioxide. Can you use the 0.2 for carbon dioxide? Cannot. Why? Because they are not the same thing. They are not the same chemical. So before you go for the next step, we always have a ratio. And the ratio is between what to what? The ratio is always between what we actually having right now is, right now I'm having ethanol, the C2H5OH, but I'm looking for carbon dioxide, a ratio to what I'm looking for, which is the carbon dioxide. So what is the ratio according to equation? The ratio between C2H5OH and your CO2, look at the balance equation number in front of the chemical. Any number in front of C2H5OH? Don't have, so it's 1. Any number in front of CO2? Got, right? There's a big 2 there, right? So 2. So the ratio between these two chemicals is 1 to 2. It means that if your ethanol is 0.2, what is your carbon dioxide? Okay now. So ratio 1 to 2. So 0.2 becomes 0.4. Okay. It means that we can say number of mole of carbon dioxide is 0.4 mole. Can? All good, 0.4 mole. Once you have number of mole of CO2, yes, you can now finally use this mole to find whatever you need. So which is you're looking for volume. Guys, what's the formula for volume? Volume over molar volume. So mole is 0.2, but what's molar volume? Molar volume, they say, is at at STP. You see that? STP, 22.4 dm cube molar volume. So put it in, 22.4. So volume of carbon dioxide gas. Bring your number over, is 0.2 multiply 22.4. So you shall get 4.48. What's the unit for volume? dm cube. Okay, the volume of oxygen gas needed for the reaction at STP. So guys, the question changed to find volume of oxygen instead of finding volume of carbon dioxide. Now find volume of oxygen. Do we need to redo the whole thing? Guys, actually no need to redo the whole thing because step 1 is to find mole of ethanol. That is found. So you just have to redo. Teacher, I thought we used 0.4 at the step. Wait, guys. Wow, good eyes, guys. Good eyes. Good eyes. This one 0.4. My bad, guys. Sorry, my bad. So 0.4. Okay, so this one 0.4. I go use 0.2. Guys, test your orbit. Okay, so my final answer is supposed to be 8.96. My bad. I used the wrong number. Okay, how do you know ethanol compared to carbon dioxide is 1 to 2? Because equation. Follow equation. That's why I say, in exam, if the equation not provided, you're required to write the equation yourself. If you write the wrong equation, you also affect your calculation. So the ratio comes from equation where you look at the number in front of the balance equation. Okay, do you see CO2 in front got a 2? That is 2. No number means 1. Okay, no number means 1. All good. So from here is 1 to 2. Okay? Which is right now, if the question now change to find volume of oxygen, where is oxygen? Is that right? What is the number in front of oxygen? 3. Correct. So now what is the ratio? 1 to 3. Got it? So ratio is always be the big number in front of your chemical. Okay, so for here, we say that C2H5OH ratio to CO2, ratio to O2 is 1 to 3. Okay, 1 to 3, then 0.2, now your O2 is 0.6. So we have number of mole of oxygen is 0.6. Good. Then use the 0.6 to calculate volume. So number of mole of oxygen equals to volume over molar volume, 0.6 and 22.4. So volume of oxygen, 0.6 multiply 22.4. So 0.6 multiply 22.4. 13.44 EMQ. Okay, all good, all good, huh? So this is where they give you the equation. If they never give you equation, it will be something like B. Okay, 8 grams of magnesium oxide powder react with excess aqueous nitric acid to produce magnesium nitrate salt and water. Guys, write a balanced equation. This one must memorize my chemistry card. Remember, I give you all chemistry card before? If you don't have, never mind, the notes inside also got the table. Look for the symbol for magnesium oxide, nitric acid, produce magnesium nitrate and water. So you must recognize the names of the chemicals and then put their symbols in. So from here, we have magnesium oxide. What is magnesium oxide, guys? Want to give you a guess? The symbol for magnesium oxide? Yes, very good. So magnesium oxide is actually MgO. Why MgO? Actually, is because Mg is 2 plus, oxide is 2 minus. So Mg2 plus, O2 minus, MgO. React with nitric acid, guys. Do you know what's nitric acid? HNO3. For those of the teacher, where you get all this? Just in case you're wondering where I get all these. Okay, you go back to your notes. Okay, remember the table that I should say that contain all the formulas. Okay, listen. Let me show you. All this. Okay? Nitric acid, HNO3. MgO, magnesium is 2 plus, oxide is 2 minus. Okay, then you actually MgO combined. The oxide here is 2 minus, cation anion, so Mg 2 plus, Mg2 plus, O2 minus, then you have your MgO. Okay, all good, So with this, they say next one is magnesium to produce magnesium nitrate. So what is magnesium nitrate symbol? Magnesium nitrate, magnesium is still Mg2 plus, but nitrate is what? Find nitrate, guys, just in case you forgot again. Nitrate come. Nitrate is here. Nitrate is NO3 1 minus. Guys, remember the 3 at the bottom right is not the number of charge. It's just 1 minus. So back to the question. This is NO3 1 minus. So if you swap the number of charge, you're supposed to get Mg NO3 bracket 2. Okay, don't forget, and water plus H2O. And guys, balance equation. So there's 2 NO3, 2H. So balance equation comes with a 2 in front of your HNO3. Okay, so with this, we can continue with your stoichiometry. So which is they're looking for 8 gram. Okay, so they give you 8 gram of magnesium oxide. So this one is 8 gram. Okay, and what they're looking for is mass of magnesium nitrate. So this one, mass. Okay, now, but the good news is, do you realize MgO in front, no number. MgNO3 in front, also no number. Guys, what does it mean by both chemical no number? What is the ratio? If both chemical no number is actually 1 to 1. Okay, so do the same thing first lah. So I'll start with number of mole of MgO equals to mass over molar mass. So mass is 8 gram over MgO. What's MgO? 24 plus 16. So 8 divided 40, 0.2 mole. Okay. But then this MgO is not what you're looking for. You're looking for magnesium nitrate. So I shall ratio MgO to MgNO3 bracket 2. So the ratio is supposed to be 1 to 1. Okay, guys, now you all recognize to get ratio is following the equation balance number. Okay, and you only compare what you want and what you have. Like, do you care about HNO3? Then teacher, how about the HNO3 in front got 2? It doesn't matter because they're not looking for HNO3. Unless they're looking for HNO3, then you use the 2. But they are looking for MgNO3 2, which is just 1. Okay, 1 to 1. So if 0.2, 0.2 means your number of mole of your MgNO3 2, your magnesium nitrate, is 0.2 mole. Okay, once you have it, can you find mass? So we finally use number of mole of magnesium nitrate equals to mass over molar mass. This is 0.2. But what's the molar mass of magnesium nitrate? That one you have to do it separately lah. Okay, so it's supposed to be 24 plus NO3 times 2 is 1N3O, the whole thing multiplied 2. Okay, so the idea is you can expand is N2O6. So it will be 14 times 2 plus 16 times 3. Okay, good good So you do the math, so 14 times 2 is 28. 28 plus 48 plus 24. Wait. 16 times 3. No, like what times 3? Times 6. No wonder I press so weird. Times 6. N2O6 guys. Because I expand my 2 into my NO3. So it's N2O6. So 16, so it's 96. Yeah, so 16 times 6 is 96 plus 28 plus 24. Okay, so 0.2 equals to mass over 148. Okay, so your mass of magnesium nitrate will be 0.2 multiply 148 is 29.6 gram. Answer. Okay, guys, all good, All good, So, we have more questions, guys. After this question, we have 9B, 9C similar questions, But because our time is almost up, let me just introduce like a few things at the back, okay? So 9B and then 9C is almost the same thing. Okay, question 10 onwards is chapter 4. Chapter 4 is your group 1, okay? And then we got group 17, okay? Got question 11, got question 12, okay? So question 11 and 12 we haven't learned, so we're going to learn in the next few weeks. Okay, so don't worry, guys. All the answers is basically provided. So, which is if you want to answer, you go back to your notes, guys. If you want to see the answer, it's here. The answer is if you look at the first page, do you see there's a QR code? Okay, you can scan this for your answer lah. All the answers is already provided. Okay, but let me just go through a few things. Okay, if you go around page number 36 onwards. Page number 36 onwards there is all the described experiment that is high chance to come out in your coming exam. It means that if you want to actually practice your equation, your procedure writing, you just go to these few questions and then you try to force yourself to memorize the procedure and then you copy one time. Okay, you read the question. Okay, you see, describe the experiment. So when I say describe the experiment, means you have the right procedure. Okay, so you see, we got your heating curve, cooling curve, the procedure given. Okay, and then your magnesium oxide procedure, and then you have your lithium, sodium, potassium procedure. So these are the three common experiment for chapter 2, chapter 3, chapter 4 that is high chance to come out in your coming exam. The last question, guys, because the last question, high chance most likely is to ask you to write out procedure. So you cannot avoid memorizing procedure. So as I said, guys, this exam is the easiest exam in the next 2 years because your first exam only got chapter 2, 3, 4. So please try to memorize this because in future, you're gonna lazy. In future, when you have more syllabus, you got more experiment, you're gonna be lazy to memorize already. This is the only chance that I think memorizing your experiment procedure is worth your time. Okay, because in your coming exam, syllabus too little already. Only got 3 chapters, only got 4 chapters. So the experiment also very limited. So it's okay to try to memorize all the experiment procedure for now. Okay, so if you can, guys, read through the question, memorize the procedure, and answer and understand all the questions. Okay, can So guys, which is if okay, I will call it a day for today. But before I leave, guys, if you have any question about chemistry, you wanna WhatsApp me, just WhatsApp me anytime. Okay, can So mark down my number and I shall answer all your chemistry questions. Okay, but don't ask me all the weird questions, teacher. How's your life today? Okay. How is you and your wife? Okay. So guys, ask me anything about chemistry lah. So if okay, guys, all good. Okay, I shall see you when I see you lah. Okay. Thanks for coming, guys. See you next time. Thank you, guys. Bye bye.